So yes, we are multiplying rational expressions. Okay? So what this means is, I'm going to take the example from the book so you can look at it, and if you wanted to, you could look at it as I go through it, but it's 5ab cubed over 8c squared times 16c third over 15a squared b. So part of it is just learning. Part of it is just learning the rules of multiplying monomials, or multiplying monomials or binomials for that matter. And then being able to simplify. So what do we know about multiplying? Like look at just the two fractions. What do we know about multiplying fractions? Daniel.
You can multiply straight across.
You can multiply straight across. Yes. That's if we're dividing. That's actually tomorrow's lesson. But yeah, you could do same change flip if you're dividing fractions. Yes. Yeah, actually, there's two different ways that we could solve this problem. Daniel's method and your method. And let's start with Daniel's method here. And that's just multiplying straight across. Okay? What's 5 times 16? Yeah. 80. So yeah, 50 and 30 is 80. So you've got 80. And then A, B, C cubed. If you just multiply those, it just stays the same. We don't have any more A's. It's just A, B cubed, C cubed. And that's over, what's 8 times 15? Have that? Someone. Yes, sir? 120. It's 80 and 40. 120. And then we're left with A squared, B, C squared. Anyone have any ideas of how I could simplify from there? Yes, ma'am.
So if you split them up into like A divided by 120.
So like the like terms, kind of? Yeah, certainly. So you could split it up like 80 over 120, A over A squared, B cubed over B, C cubed over C squared. Right? And if you wanted it, if it makes it easier for you to split them up like this, certainly go about it. If you want to just deal with it all in one line, that's fine too. So, how can I simplify 80 over 120? Yes, sir?
What is that on 80? 40 goes in the place.
Okay, so that reduces to 2/3. Perfect. How would I simplify A over A squared, Riley?
1 over 8.
1 over A. Perfect. Yeah, because there's 2 down here and 1 up there. It's just 1 over A. Excellent. How do I simplify B cubed over B? Yes, sir. B squared over 1. I want to be square. And then C cubed over C squared. Full. 1 over C over 1. Good. Just C over 1. And then to finalize this, what we do is you're going to have 2 times 1 is 2. So it's going to be 2 B squared C.
Really?
Over 3A. Because you don't have to do the 2 1s. So it simplifies for that. If it asks you to state the excluded values, what would our excluded values be in this case? 0. Actually, A couldn't equal 0, B couldn't equal 0, or C couldn't equal 0 because we do have it actually comes up to here. Not just the last one, but any of those couldn't equal 0. What's that? What's the excluded value? A can't equal 0, B can't equal 0, or C can't equal 0. What? Yes, there are. There are 3 of them. A can't equal 0, B can't equal 0, and C can't equal 0. What? Okay, so if A equals 0, let's put it in here. We have 80 times 0 times B to the third times C to the third over 120 times 0 squared. Something silent to work about your fidgetiness. Okay, right, Paul? What's this going to equal? 0 over 0. That you cannot do 0 over 0. That is, put in your calculator, it's going to say syntax error. You can never divide by 0. Okay? So it doesn't matter what B or C is, that's going to equal 0. All right, so Andy suggested that we look at a different method. And you may choose to use this method because multiplication is a little easier. If you take this, let's take it for a second. And can we stop the snapping, please?
I can't stop.
If we take this same problem, and let's look at it like this. Let's just take and write straight across 5 A B cubed times 16C to the third over 8C squared times 15A to the second B. Now, if we look at if there's anything we can reduce on the top and bottom here, we can simplify. So 5 and 15. Both 5 goes into that, so that would be 1, and this would be 3. And then you could take 8 and 16. They have a common factor of 8, so that would be 1, and that would be 2.
Plus you.
C squared and C to the third. That becomes C to the first. B cubed and B. This becomes B to the second. That's just 1. A and A squared. That just becomes just A to the first. So now you look at everything that you have left. You have 1 times B squared times 2 times 1. That would equal 2B squared C over 3A. So you don't actually have to, in this one, you don't actually have to divide, or you don't have to do all that multiplication. You're just simply crossing it out. So you can use either method that you would like. It doesn't matter how you go about it. It just depends if you want to see it all written out or if you want to reduce it like this. So let's try another one, and I want you to pick a method, and I want you to try it this time.
What is CB squared? C. What is B squared?
7x squared y over 12 c cubed times 14 c over 49 x y
Cube.
All right, there you go. You may be. All right, show us what you did. What'd you do first?
So first I multiplied across. I got,
So you did like 7 times 14?
yeah.
Okay.
$98x squared C. So when I multiplied the denominators, I got
588.
So then once I got that, I did 588 divided by 98. and that reduced it down to 1/6. And then I just took that, and then paired up each letter. And then once I got there, I just put it all together and got it down to one big answer.
Maybe not the best explanation in the world, but he is accurate. What is hard about this method? Jenna? Multiplication. And not that it's hard, it's time consuming. Especially if you're not using a calculator. And then you have to actually divide too. You have to find a common factor for 58 and 5 or 98 and 588. In this case it worked out nice, Cole, that 98 went into 588. Okay, it went into it fairly easy. It's not always going to work out like that. So one thing I wanted to do, I actually was hoping that someone would do it that way. I wanted to show you the second method and why I think this method is a little bit easier to go to begin with. So I just take and I'm going to write this, just make it a whole big fraction like that. I know that this is times and times, but now I just look for any common factors in the numerator and the denominator. So looking at this, can you tell me any common factors that are up there? 7. 7 and what? 7 and 2. So in the numerator and the denominator, Braden, is there something that you could divide any of these by? So I mean, if I look at this, is there a common factor between 7 and 12? How about 7 and 49?
Yeah.
Okay, what's the common factor between 7 and 49?
7.
7. So it's just worry about the whole numbers here to begin with. It's 7 in this case. That's left with 1 and 7. Anyone see any other common factors up there? Brendan?
2.
2 for what?
12 and 14.
It goes into 12 and 14. Good. That's a 7. That's a 6. Do we see any other common factors with the whole numbers? Cole?
7 and 7.
7 and 7. They cancel each other out, and that becomes 1 over 1. 7 over 7 is the same thing as 1 over 1. Now, I would worry about the variables. Now I've got the only thing I have left is a 6 here, and 1 goes into all this, but we don't need it. It's that simplified. So now I can look at my x squared. I know this gets kind of messy. That x squared and the x leaves me with 1x on top. And then I've got z to the third and z. And cross that out, I'm left with z squared. Y to the fourth, and y, that's 1. That's y to the third. Now I just look at what I have left. I've got 1, I've got an x, I've got a 1, I've got a 1, I've got nothing there. So all I have left on the top is an x. On the bottom, I'm left with 6 z squared y to the third. I'm sure there's probably a way to do this where it's not quite as messy. Maybe use colored pencils or something. But don't you agree that that's a little bit easier of a way to do it?
No.
I know I got my answer like that, where Jared got this right at the very end, because he was sitting there multiplying and dividing. It took him a little longer than it took mine. So at this time, I've got one more for you to try. 5c squared d to the fourth. 5c squared d to the fourth.
This is going to be fun.
Over 18 q to the third r times 6 q to the 5th r to the 4th 16 c squared d squared.
That's interesting.
Okay, go ahead and solve that one. Okay, so a problem like this, what we're going to start by doing is, I just like to make a fraction bar all the way across. I know that's times and that's times. At this point, I'm going to start to simplify. You can't, notice 18 and 60, they've got a common factor of 2 or even 3. You can't simplify those two. You can only simplify if there's a common denominator between, or a common factor between the numerator and the denominator. That's where we can simplify. You can't simplify if they have a common factor like between 3 on 18 and 60. So just remember that. But I'm going to start the way I started on this one. I simplified 5 and 60. So the 5 became 1. That just canceled that one out. And this becomes 12. And then I saw here 12 and 6. That's 1 and that's 2. And I couldn't simplify anything else because I've got just all my whole numbers on top are 1. You could have, if you wanted to, you could have simplified 18 and 6 instead. The 6 goes into 18, that would have been 3, and then, but it doesn't matter, you'll still get the same answer. Then I look to see, are there any C's? Well, those cancel each other out. D's, we have D to the 2nd. That's canceled out there. Q to the 2nd, 5 minus 3 is 2. And R to the 4th becomes R to the 3rd because there was 1 R underneath. So now I look what I have left. I've got D squared, Q squared, R to the 3rd, all over. In this case, it's just 18 and 2, so 18 times 2 is 36. Did you get that, Lucas? Okay. Are there any questions about this? Okay. Let's move on to the next item. The next thing that we have to do is expressions involving polynomials. Okay. So this would be something like, and I'm going to show you the one in the book to begin with, x minus 5 over x times x squared over x squared minus 2x minus 15. What do you think we do to begin with here? Yes, sir. How would we simplify? Well, in this case, if I have this, remember it's multiplication across. I can't necessarily simplify anything yet. What I want to do is I want to start by taking and factoring this out. Okay, so taking this whole thing and factoring this. So I've got x minus 5 over x times x squared, and who can factor that for me? X minus 5 times x plus 3. And we'll come back to that when you get back. So now that we have this, notice we have after we factored this, we've got an x minus 5 common in both the numerator and the denominator. So I can even take this fraction bar and just extend it across. And I've got this x minus 5 here and this x minus 5 here. So those binomials there cancel each other out. We also have an x and an x squared. That becomes just x over that. This is a binomial, so this x is related to the plus 3, so we can't cancel those x's out. Yes. Okay. So we're left with x over x plus 3. Okay? So what we're going to do is we always, when we have these, we're going to factor first. Look for anything we can factor. Look for a greatest common factor. Where it's not a greatest common factor, then we're going to, we can use our factoring process, multiplying to negative 15, adding to negative 2. Okay? Typically, or in these type of problems are set up like that, but let's look at another example. And this one's from the book. Also, it is a squared plus 7a plus 10 all over a plus 1 times 3a plus 3 over a plus 2. All right, so here is our problem. And again, we want to look for anything that we can factor. If we have a trinomial, we want to see if there's a greatest common factor. If not, let's factor it by multiplying and adding. So let's look at this. Can we factor this part of the equation? Okay, how would I factor that? How would I factor that? Daniel?
5 multiplies to 10, and the answer 7.
And
would be 2 and 5.
Okay, so a plus 5 times a plus 2. And it's really easy when the leading coefficient is 1. Okay? Okay, and then can I factor 3a plus 3? Jaden, can I factor 3a plus 3?
No.
No? Is there a greatest common factor?
Oh, yeah.
3, right? So this would be 3 times, I know that's still a plus 1. Can I factor a plus 1? That's simplified, correct? So I've got a plus 1. I like to put them all in parentheses. And I've got a plus 2. So now I can start to simplify. Turn around, please. A plus 1, a plus 1, a plus 2, a plus 2. So what I'm left with is a plus 5 times 3 over, what do you think it's over? 1. Okay, or you don't even have to write that 1. So in this case, this would equal, we can either write 3 times a plus 5, or we can write 3a plus 15.
This is very simple.
It probably makes most sense to write it in expanded form there, rather than factored form. But I wouldn't mark either one wrong. Okay, so why don't I have you try one of these? B squared minus 4b. Plus 3. Okay. So why don't you go ahead and attack that problem? Let's go ahead and take a look at these. I like to look at every single binomial or trinomial as we come along to it. So I know I've got the b plus 3. That's simplified. Since it's multiplication, I'm just going to put it all in parentheses. Now, b squared minus 4b plus 3. I know that I can factor that. I'm multiplying to positive 3 and adding to negative 4. So I know they have to both be negatives to add to positive, or to multiply to positive 3. And then this, I'm going to look for a greatest common factor. In this case, it's 4. And then this multiplying to negative 30, but adding to negative 7. I've got b, what was that? Is that 10?
B minus negative 10, B positive 3.
Thank you. Now I start to look for binomials that I can cancel out. B minus 3 and b minus 3. B plus 3, b plus 3, and that's it. So I'm left with b minus 1 over 4 times b minus 10. I would probably write it like that. I would take either of these answers, though, at the end. Okay, our last, feeling okay about those?
Yes.
Our last topic kind of puts these all together. These are, I like as the fun problems.
Ben?
In the book, it says, in the 2000 Summer Olympics in Sydney, Australia, Maurice Green of the United States won the gold medal for the 100-meter sprint. His winning time was 9.87 seconds, so it's a 100-meter sprint. His winning time was 9.87 seconds. What was his speed in kilometers per hour? Round to the nearest 100. So we want to know how fast he was running. We can even convert this to miles per hour since we use more miles per hour. But let's start by doing kilometers per hour. Okay? So what do we know? We know that he ran 100 meters in 9.87 seconds. So if we want to know kilometers per hour, we got to transfer this into kilometers. We got to get meters into kilometers. So we know that 1 kilometer equals 1,000 meters. And we also need to do this. We also need to do, instead of seconds, we need what? Hours. Okay, so we know that there are 60 seconds in 1 minute, and that there are 60 minutes in 1 hour. So eventually what we want to know is we want to know a number in miles, not miles, kilometers per hour. Okay, so that's what we're shooting for, is kilometers over hours. Okay, and then we'll have a number. So now we can start to simplify. Okay, we can start to simplify. Ooh, this is seconds. So starting with this, let's go ahead and simplify. Since we have meters here and meters here, they cancel each other out. I've got a minutes here and a minutes here, they cancel each other out. I've got a seconds here and a seconds there. They cancel each other out. And notice we're left with just kilometers and hours. So now we've got kilometers per hour. And I could do 100 times 60 times 60. But I'd rather simplify it before that. I've got a 100 and 1,000 here. 100 goes into both of these. And notice I've got a 10 and a 60. 10 goes into both of these. So now I got it where it's a little more manageable, and I can do it in my head. I can do 1 times 6 times 60. I'll erase this for a second. That's 360 kilometers over 9.87 times 1 times 1 times 1 over 9.87 hours.
That's a crazy number.
So what this is saying is this guy can run 360 kilometers in 9.87 hours. That's if he was running at his full speed and didn't slow down. We know that a sprinter can't do that. Usain Bolt can run really fast. He can run under 10 seconds. I don't know what it was.
It's like 9 foot.
Yeah, it's super fast. But in this case, he can't do that for a full hour. He can't do it for that long. So anyway, what we're going to do now is, someone with a calculator out there, can we do 360 divided by 9.87? Got it?
Oh, wait, did you want it as a fraction or divided by?
360 divided by 9.87.
36.
36. Stop talking.
36.47.
Nope, I got it.
I don't want it as a fraction, I want it as a
Decimal?
decimal.
I got it as decimal.
36.
0.47.
Like down.
Let's just keep it right there.
It's like.
So this means if he was running at 36, if he was running at this speed for a full hour, he could run 36 kilometers. A kilometer is about 0.62 miles. Okay. We can even Google that if we wanted to. I mean, that's usually how I convert it into miles per hour.
22 miles an hour. 22 and a half miles an hour.
What's that?
22 and a half miles.
22? There you go.
What are you doing?
Just do a miles kilometer to me.
And you had, what'd you have?
22.61.
22.61. And we use an estimation that a kilometer is about 0.62. So yeah, it's 22.6. So he's running at 22.66 miles per hour. That's pretty darn fast. That's a pretty good effort by myself on my bike. I can sustain that on my bike for maybe an hour by myself. Where he couldn't run an hour at that speed. He'd be done.
Yeah.
Yes.
So he runs faster than our naval warships during World War II.
Yes. For 10 seconds. Now, I'm going to have you try these problems on your homework. Okay, just try setting them up like I did. But I certainly know that we only did one problem like that. I've got several for you to try. But go back to your book and look at that example. If you have trouble with them, we will come back to them tomorrow. Okay, but I want to give you a chance to work on your homework in class today and see if you can finish it. So let me give you your homework assignment. Okay, page 657. I will write this down in classroom as an announcement. But I strongly suggest that you write this down at this point.